And then the last one. The last practical one, because again, this one allows DC in, right? This is an open, that's good, and this is a short to DC. The last one, that practical one that will allow DC in, will then have to look like this. It will first have a shunt C, and then it will have your series L. So we want to use that one to bring ZL to Z naught. So what do you think about that one? Where do you think that one might be?
The other half of the Smith chart?
Yeah. Just double check something. Yeah, this. Yes, the other half of the Smith chart. And the way and why do you say that? Why the other half? So how would we? Let's say that we have a point here. Let's say that this is our ZL. So how would I then be able to match it to Z0?
You move like your capacitor to R equals 1, and then, no, wait.
Well, how do I, okay, this is a more basic question. So let's say my ZL is here, and I want to find Z1, which I'm going to define here, right after this capacitor. How do I do it? How do I use the Smith chart to do that?
Y chart.
Yeah, you have to go to the Y chart, right? So you have to find the equivalent YL, right? So YL is going to be somewhere here, okay? And then you add your capacitance, okay? So then you're going to add your capacitance, and you're going to bring it here, okay? Then you're going to go back to the Z chart, and then you're going to use an inductor to bring it to the center. Now, the way to think about the region, is again, you can think about it from the output in, and say, all right, I'm going to, my L, I know that my L is going to bring Z1, has to bring Z1 to Z0, right? And the only way an L can do that is if Z1 was on this arc, right? That's the only way an L can do that. So Z1 better be on this arc, okay? But now I need to figure out what is ZL. Well, I have a shunt C there, so I better go to the Y chart. Anything shunt, I should be on the Y chart. So Z1 goes to Y1 here, okay? So my Y1 better be here, okay? Now, a capacitor is, okay, so how do I, where should ZL lie on the, okay, so where should YL lie now, so that YL can go here, can go to this semicircle, right? Because YL has to go to Y1, so it better be below, it better be in the same green region, except it's on the Y chart. So on the Z chart, it's the opposite. Okay, you understand? So that's what we're going to be studying. So this is, you're going to be designing these matching networks. You're going to be given some impedance, and then you will figure out, well, where is that impedance on the Smith chart? What type of matching network of these four should I use? And what are the values for the components? And this class of matching networks is again lumped element matching networks. Next time after the midterm, we're going to go over stub matching, where you're actually using transmission lines, open-ended or short-ended transmission lines to design your matching networks.